Welcome to Unit 5. Our first video is on graphing systems. You will see here that there are three different possibilities that we can have when we graph systems of equations. Our first one is just simply when we have two lines that intersect at a point. That would be our solution for that system. So that's a one solution type. Our second is when we have two lines but they don't intersect. We see that the lines are parallel for these. When they are parallel, the slopes are the same, okay? But our y-intercepts are different. So there is no solution for this type of problem. And our last one is when we have one line, but as we can see, there are perhaps two different lines with our arrows there. That's when the slopes are the same and the y-intercepts are the same. So when our two equations are graphed, we get the same line. That means that there are infinitely many solutions here. Here's our first problem. What is the solution to this system? Well, if I'm looking at the graph, I see where they intersect. So they intersect right at this point. Well, that's the ordered pair 1, 1. That is our solution. Okay. This problem asks us if -5, 7 is a solution to this system. Well, if it's a solution, the best way to check is to plug it in. So we're going to plug in the x and the y in for our equations. So we're going to do -8. We're going to plug in -5 in for x, plus 10 times my 7, which is the y, equals -30. We're going to test that out, see if it works. So this is 40 when I multiply, plus 70 equals -30. So that's 40 plus 70, that's 110 equals -30. Well, if I think about that, that's not true, okay? That's false. If it's false for one equation, it doesn't matter if I do the other equation or not. It could be true in the other equation, but again, it doesn't matter. So this is not a solution. It has to satisfy both equations. It has to be true in both equations. Let's go ahead and try to graph some of these. Well, we have two lines that are in slope-intercept form. We're going to have to find the m and the b for both of them. All right, so our first one, our m is 1/2. And our b is 3. That's our y-intercept, remember? So we're just going to plot that. And we do our slope, up 1 over 2. Or we could go down 1, left 2. So we're going to get a line here. It's ideal that you make your lines as straight as possible. Because if they're not as straight as possible, you might be off a tad when you are seeing your intersection. Our second one here, y equals -x minus 3. Our slope is -1 over 1, because there's a 1 right there. And our b or our y-intercept is -3. So again, we're going to plot -3. And we're going to go down 1, right 1. Down 1, right 1. We could go up 1, left 1. Up 1, left 1. All right, we're going to draw a line here as well. Again, really try to make it as straight as possible. All right. So there's our graphs. Why don't I just extend this a tad? Okay. Well, if I look, where do they intersect? They intersect right here at this ordered pair. that point. So our solution is an ordered pair. Our solution is the ordered pair -1, 2, 3, 4, -4, comma, up 1. So -4, 1 is our solution. Our last example here is, again, two equations in slope-intercept form. We're going to go ahead and find our slope and y-intercept again. So I see it's 2/3 because that's our m, and our b is -2. So I'm going to plot that -2 here. Slope says to go up 2, right 3. We could go down 2, left 3. Make a nice straight line. Okay. Let's do another one here. This one is, hey, notice it's the same slope. Think about what happens when it's the same slope. Our y-intercept is 1. We plot 1. We go up 2, right 3. Or we could go down 2, left 3. Make it nice and straight. Notice, what do the lines do? Okay, these are parallel. So when they're parallel, there is no solution because they don't intersect. Remember, if you need a solution, they have to intersect. All right, there you have it. That's solving systems by graphing.